Dr. Vimlathithan Rathina Sabapati, Professor and Head of the Department of Electronics and Communication Engineering in Aditya Institute of Technology, Coimbatore. Doctorate in the field of crypt analysis in Government College of Technology, Coimbatore. Postdoctoral Fellow in the Department of Information Engineering, University of Padova, Italy. He is very much interested in research area of cryptography, crypt analysis, electromagnetic interference, compatibility, antenna design, wireless sensor network and communication. He has published papers in international journals and international national conferences. He is a reviewer of journals like DRDO, WSCAS, International Journal of Network Security, and also have a membership in professional bodies like CRSI, IACR, and Computer Society of India.
Welcome to UGC lecture series Communication Electronics for Applied Electronics. In the today's session, we are going to see about the delta modulation and adaptive delta modulation. Why delta modulation? And what is the necessity for delta modulation? If you take PCM, that is a pulse code modulation, it is uniformly coded and the size of the code words are uniform and it can be easily integrated with any other networks in a common channel. But there are a lot of disadvantages of PCM. In PCM, it transmits all the bits and here the channel bandwidth is required is more, but there are a lot of advantages, but in case of PCM the main disadvantage is transmission bandwidth, but in nowadays we have to effectively utilize the available bandwidth due to increasing the channel capacity or channel requirement. The bandwidth have to be utilized effectively. If a single channel PCM occupies more bandwidth, then the channel is not utilized effectively. So, we have to reduce the bandwidth, at the same time we have to transmit the information without any loss. So, we go for a new type of technique called delta modulation. Mainly this delta modulation is preferred to overcome the channel bandwidth requirement for PCM. Here in case of delta modulation, it transmits only 1 bit per sample and here the present sample value is compared with the previous sample and whether the amplitude is increased or decreased, that is 2 successive samples are taken and then it is compared whether the current sample is greater than the previous sample or if it is less than the previous sample. Based on this information we transmit an information. In delta modulation, incoming message is oversampled, that is at the rate much higher than the Nyquist rate. If you take the Nyquist rate, Fs should be at least twice the F max, that is F max is the maximum signal frequency component. We can sample the signal even at Fs equal to F max, that is the sampling frequency will be equal to 2 F max, but if you sample at a higher rate, that is Fs is very greater than 2 F max, so that is preferred in delta modulation. This is because to increase the correlation between the successive samples. We already discussed, if you take the more number of samples, then the samples will be very close to each other and the distance between the successive samples is very close. So, this is the requirement in case of delta modulation, because we are comparing 2 successive samples. If they are very close, then we can retain the original information. If they are far apart, then it is very difficult to maintain the original information. So, that is why we have to sample at a very higher rate when compared to the Nyquist rate, that is Fs should be very greater than 2 F max. This is preferred in delta modulation. So, this is done to permit the use of simple quantizing strategy for constructing the encoded signal, and this delta modulation provides a staircase approximation to the oversampled version of the message signal. That is the difference between the input and the approximation is quantized into only 2 levels, that is either plus or minus del, that is the step size is only 2 levels corresponding to the positive or negative difference, that is if the current sample is greater than the previous sample, then positive del is used, and if the current sample is less than the previous sample, then negative del is used. This shows the quantized signal and the original signal and the generated binary data. We will see how this data is generated. The principle of delta modulation, that is, here this can be explained using these equations. Here we have E of NTS, and that is equal to x of NTS minus x cap of NTS. So, NTS is nothing but the discrete time instant, E corresponds to the error, and x corresponds to the sampled signal of x of t, that is sampled version of the original message, and x cap of t is nothing but the last sample approximation of the staircase waveform. We can consider the present sample as u of NTS and the last sample as u of n minus 1 Ts, that is we have discussed in the previous slide, that is x cap is the last sample approximation. For simplicity, we are representing this x cap as u of n minus 1 Ts. So, this is the current sample and this is the previous sample. And now, if you take the error E, which is the difference of the current sample and the previous sample, and now we are going to provide a bit B based on the error. Here we use a sine function, this SGN function. So, let us take a general function SGN of x. So, here this will generate only two outputs, either plus 1 or minus 1, that depends on the value of x. Here the threshold value is 0, that is if x is greater than 0, then sine of x will be positive. If x is less than 0, then the sine of x will be negative. So, this one will generate only two outputs, that is it will be plus 1 and minus 1, two values. So, if the error is positive, then this value will be plus 1, and if the error is negative, then this value will be minus 1. As we already seen, that is in case of delta modulation, only two values are transmitted, plus del and minus del. So, if the current sample is greater than the previous sample, then the error will be positive. So, this sign of the positive value will generate plus 1. So, the bit will be plus del, and if the error is negative, then this B will be minus del. So, this depends on the sign of the error. Here this B takes plus del if the current sample is greater than the previous sample, and it takes minus del if the current sample is less than the previous sample. If the step size is plus del, then 1 is transmitted. If the step size is minus del, then 0 is transmitted. So, this shows the block diagram of a delta modulation transmitter. As we already seen that this DM is uses 1 bit quantizer. Here the sampled message signal is provided as input to a comparator, that is x of t, that is m of n here. So, this is the current sample. Here for the comparator we are providing another input, which is the previous sample. This previous sample is generated using a delay unit, that is z power minus 1. So, this z power minus 1 will generate a sample which is delayed by 1 unit. So, if we have mq of n, then this z power minus 1 will generate mq of n minus 1. So, based on the current sample and the previous sample, an error is generated, and that is used as an input for the 1 bit quantizer. Here the output will be that is quantized value of the input, that value is encoded using an encoder. As we have seen that equation, the error E, that is equal to x of NTS minus x cap of NTS, that is current sample compared with the previous sample. If this is greater than this one, then the error is positive. So, here if the error is positive, then plus del is generated, plus del is the output, and if plus del is the output, then it is encoded as 1. So, this is done by this block encoder. If the current sample is less than the previous sample, then the 1 bit quantizer will produce minus del, and this encoder will encode as 0. So, this is the block diagram of a delta modulation transmitter. So, this graph shows about the message signal and the quantized signal, and then you will compare both the current and previous one. So, based on that, the coding what you have discussed. So, this is the bit pattern generated for this signal. It is 0, 1, 1, 1, 1. If you see here, this is higher, and if you see here, this is lower. So, 0, 0, 0, 1. So, this is the way of generating a delta modulated signal. So, this block diagram shows about the receiver of for the delta modulation. Here the first block is a decoder, and the next block is an accumulator. Here this accumulator have one feedback path, that is the output is delayed by 1 unit and it is added again, and then it is passed through a low pass filter. This decoder, so based on the incoming data, whether it is 1 or 0, this will decide. So, at the transmitter, if we have the positive step size, then 1 is transmitted, and if we have the negative step size, then 0 is transmitted. So, we have to do the reverse process here. If 1 is received, then plus del is transmitted at the transmitter. So, we have to decode appropriately. The summer in the accumulator adds the quantizer output with the previous sample approximation, and this gives the present sample approximation u, that is this is for transmitter, that is this is nothing but the current sample. So, u of n t s minus t s plus or minus del. So, this is nothing but the bit generated. So, in case of transmitter, the sampled input signal and the staircase approximated signal are subtracted to get the error signal. So, depending upon the error signal, 1 bit quantizer produces an output step of plus del, then the binary will be 1 and it is transmitted, and if the output is minus del, then the binary 0 is transmitted. In the receiver side, an accumulator and a low pass filter are used. The accumulator generates the staircase approximated signal and the output is delayed by one sample period T s, then it is added to the input signal. That is, we have seen an accumulator, it have one feedback path that is delayed by 1 unit. As when the input is binary 1 is received, then it adds plus del step to the previous output, that is which is delayed. If the input is 0, that is this is in the case of receiver, if the received data is 0, then one step del is subtracted from the delayed signal. So, this is done at the reception side, and then this data is passed through a low pass filter whose cutoff frequency is the maximum frequency available in the message signal. Basically, this filter is used to smoothen the staircase, reconstruct the signal x of t. Now, we will see the advantage of delta modulation. Delta modulation transmits only 1 bit for one sample, and thus the signaling rate and the transmission channel bandwidth is quite small for delta modulation, and it is very simple to implement the transmitter and receiver in case of delta modulation, and there is no need to have an analog to digital converter in delta modulation. And the disadvantage of delta modulation, if we consider the signal, this is the original signal, let us take m of t is the original signal, and if we find the slope of the signal can be computed. This slope gives the variation of this signal. If we consider here, the variation is very high, the slope is high, but whereas if we consider here this signal, the variation is low, that is the signal is like this, is almost straight, there is no variation, but whereas here the signal varies high, that is the slope is high. So, in case of delta modulation, there are two possible errors. One is called as slope overload distortion or slope overload noise and granular noise. So, this slope overload noise is seen at the signal if it have higher slope, that is the variation is high. So, that the delta modulation have to respond to the high variation. It is very difficult for the circuit to respond to the high variation. So, there may be possibility of slope overload distortion. The condition required for step size should be, this gives the slope and the maximum of the slope, del by Ts, del is the step size and Ts is the sampling interval. This ratio should be greater than this maximum of the slope. That is, there are two possible types of error in the delta modulation, that is slope overload distortion and granular noise. This distortion arises because of the large dynamic range of the input signal. From the quantization error of the delta modulation figure, the rate of rise of input signal is so high, so that the staircase signal cannot approximate at it. The step size becomes too small for staircase signal to follow the steep segment of x of t, that is the slope is high, that is the variation is high. So, it is very difficult for the staircase to follow. So, the large error exists between the staircase approximated signal and the original input signal. So, this type of error is called as slope overload distortion. So, this can be reduced by increasing the step size when the slope of the signal is high. Since the step size of the delta modulator remains fixed, its maximum or minimum slope occurs along the straight line. So, it is called as linear delta modulator. And the next one is granular noise. So, this granular noise is seen when the slope is very minimum or the step size is too large, too small variation in the input signal. If you see that graph, that is straight path, there is no variation. So, in that case, when the step size is too large when compared to the variation, variation is very minimum and the step size is large, then we can see the granular noise. So, very small variations in the input signal, staircase signal is changed by large amount because of large step size. So, from the quantization error of the delta modulation figure, when the input signal is almost flat, the staircase signal u of t keeps on oscillating between plus and minus around the signal. The error between the input and approximate signal is called as granular noise. To reduce the granular noise, we have to make the step size small. Thus, a large step size is required to accommodate wide range of input signal and small step size is required to reduce granular noise. That is, to avoid the slope overload distortion or slope overload noise and granular noise, we go for another technique called adaptive delta modulation. In this case, the step size is adaptive, that is variable. That is, in case of delta modulation, the step size is fixed. Before that, we will see another type of modulation called delta sigma modulation. Here, this is almost same as that of a delta sigma modulation, but one block is added along with the delta modulation, that is called as sigma block. Sigma is nothing but simply a summation or an integrator. This delta modulator calculates the difference between the input and predicted signal, that is, operation is equivalent to evaluating derivative of the input signal, that is the difference. The difference is mathematically called as derivative. The problem present in the delta modulation will be the noisy data can cause cumulative errors in the demodulated signal. If the signal has DC component, then the errors are created in the demodulation side. This problem can be easily eliminated using an integrator or an accumulator before the delta modulation. That is, accumulator is nothing but summation. So, this is mathematical operation and we call it as an accumulator, or integrator is also an accumulator. To be specific, we have to call this as SDM, that is sigma delta modulation. This is the first block, that is sigma block, and this is the delta modulator. So, this can be shortly called as SDM. So, this is based on the operation performed, first sigma operation and delta modulation operation. At the reception side, we have to do the reverse process, that is at the transmitter we have done the integration, that is summation process or accumulation process. So, at the reception side we have to do the differentiator process. The first block is the differentiator, and then this will be a delta modulators receiver section, basically it is a demodulator. The problem in the delta modulation can be eliminated by using an integrator or accumulator before the DM, and sigma stands for integration or accumulation. In the receiver, the operation performed by differentiator and accumulator cancels each other. So, the total block will be is equivalent to a low pass filter. Advantage of delta sigma modulation: due to the integration process as the first block, the low frequency input signals are pre-emphasized and the correlation between the adjacent samples are increased. This reduces the variance of error, and the receiver is almost simple because it contains a low pass filter. The next one we will see about the adaptive delta modulation. That is, in case of delta modulation, we have seen about the two types of noises: slope overload distortion and granular noise because of fixed step size, and based on the slope, that is variation of the input signal. So, it may cause slope overload distortion or granular noise. So, to avoid this, we go for an adaptive delta modulation where the step size is adaptive or logically controlled. It is what we discussed is to overcome the quantization error due to slope overload and granular noise, the step size is made adaptive. Particularly in the steep segment of the signal, the step size is increased, and when the input is varying slowly, the step size is reduced. This can be done automatically using an adaptive circuit that can be used in the delta modulator. So, this block diagram shows about the adaptive delta modulation, and here we have the, if you see, compare this block diagram and the delta modulator, we have a new block added which is called as adaptive step control, and the remaining will be almost same. And here we have a delay TS. So, previously we have represented using an Z power minus 1. Z power minus 1 is also a delay unit. So, here it is delayed by 1 unit, that is 1 time period. Here based on that variation, here we have an adaptive step control. This will control the step size del, and then here this shows about the adaptive delta modulation receiver side. So, this is the receiver side. Here the input is applied to a logic for step size control, that is adaptive step size control, and then it is passed through the reception. It is like a normal delta modulation receiver, but here we have one more block called logic step size for control, that is adaptive step control. So, this is used at the reception side, that is for demodulating the adaptive delta modulated signal. The adaptive delta modulators can take continuous changes in step size or discrete changes in step size. In the block diagram, the logic step size control is added, that is adaptive controller. The step size increases or decreases according to the certain rule depending upon the 1 bit quantizer, that is certain rule is nothing but based on the slope, that is variation of the input signal. For example, if 1 bit quantizer output is 1, then the step size may be double for next sample. If the 1 bit quantizer is low, then the step size may be reduced by 1 step. In the case of receiver of adaptive delta modulator, the first part generates the step size from each incoming bit, that is we have seen the logic control that controls the step size, exactly the same process done at the transmitter. The previous input and present input decides the step size. and it is then given to the accumulator which builds the staircase waveform, and the low pass filter smoothens the staircase waveform to reconstruct the signal. And the next one is continuously variable slope delta modulation. In adaptive delta modulation, the step size changes in discrete steps. When the step size varies continuously, then it is called as continuously variable slope delta modulation. The advantage of delta modulation: the signal to noise ratio is better than the ordinary delta modulation because of the reduction in slope overload distortion and granular noise. Because of the variable step size, the dynamic range of adaptive delta modulation is wide, and the bandwidth utilization is better when compared to the delta modulation, and only 1 bit per sample is required and simple in implementation of transmitter and receiver. Conclusion: in the today's class we have discussed about the delta modulation, and then why we go for delta modulation instead of PCM, and then we have discussed about delta sigma modulation, and then we have discussed about the granular noise and slope overload noise, which are the main parameters that affects the performance of delta modulators, and then we have discussed about the adaptive delta modulation. Questions: what is slope overload distortion and what is meant by granular noise? Give the difference between delta modulation and adaptive delta modulation. Thank you.